Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. The learning objectives for today's session are number 1, study of steering system and terms related to it. Steering system, second part of control system, that is steering system, started today will be started today, and from the today 3 session it will be completed. Hmm. First objective is study of steering system and the terms related to it. Second, study of basic components of steering linkages, how steering linkages are connected and what are the basic components of steering linkages will also be studied in today's session. Starting with first, steering system. The steering system allows the driver to guide the moving vehicle on road and to turn it right or left as he desires. The need of the steering system is the during steering the movement of the wheel must be positive and exact and no wheel should slide on road. This aspect is influenced by the steering linkage mechanism, tire road condition and vehicle suspension system. In order to maintain proper control through its speed, with safety in straight ahead motion as well as during turning, mm, bump and bounce, provide directional change with minimum effort of driver, steering mechanism is provided. Mechanism used for turning the vehicle or to provide directional stability to the vehicle is called as steering mechanism. When a vehicle is moving on a road surface, the relative motion between the wheel and the road surface should be pure rolling motion. This condition must be satisfied when the vehicle is moving along the curved paths. This makes steering system more necessary for turning or for controlling of an automobile system. The purpose or requirement of steering system is the steering system should be very accurate and it should be easy to handle. It should multiply the effort applied on the steering wheel by the driver. It should be certain degree irreversible so that shocks on the road surface encountered by wheels are not transmitted to driver's hand, and the steering mechanism should have self-rightening effect, that is when the driver releases the steering wheel it should come back to its original position and achieve the straight ahead position. So these are the requirements of an steering system. Next is function of a steering system. Function are also same. That is, it should help the wheel to swing left and right. It should provide directional stability. It should help the turn the vehicle at the wheel of the driver. It help in controlling the wear and tear of an tires. It helps in achieving self-rightening effect. It converts rotary movement of steering wheel into angular movement of front wheels. It should multiply the driver effort by leverage to make it easy to turn the wheels, and it should absorb road shocks, thereby prevent them to get transmitted to the hands of the driver. So these are the all functions of steering system. Starting with the basic terms related to steering. The first term is steering ratio, or also known as reduction ratio. Steering ratio is defined as number of turn on steering wheel to produce 1 turn of steering gear cross shaft when the pitman arm is attached to it. That is, the number of turn on a steering wheel produced to steel to produce 1 turn of steering gear, that is to produce the 1 turn of an steering gearbox. The steering ratio varies from between 14 is to 1 and 24 is to 1 in case of passenger cars. It grows with the bigger size of the car, low car, light car, the different steering ratio for different types of car. There are different types of gear which have different reduction ratio. By varying the pitch of worm oblique cam, so that it is flatter at the center. It is large for straight ahead, while for outer range it is lower. The gear ratio can be defined by considering the turning of cross shaft. It turns much less than the completing the rotation in operation. Therefore, the gear ratio is the ratio between number of degrees of rotation of steering wheel and the number of degrees through which the cross shaft turn or rotates. So, steering ratio is nothing but the number of turn on a steering wheel to produce one turn of steering gear cross shaft. The next basic term related to steering is turning radius. The turning radius or turning circle of an vehicle is the radius of smallest circular turn that a vehicle is capable, or when vehicle takes an U-turn, the radius is called as turning radius. It depends upon maximum angle of front wheel can turn and the wheel base. The radius of circle on which the outside front wheel moves when the front wheel turn to extreme outer position is known as turning radius. Turning radius varies from 5 meter to 8 meter for passenger car and can be up to 15 meter for bus and truck. It is proportional to the wheelbase of an vehicle. The next basic term related to steering is understeering and oversteering. When taking the turn, the centrifugal force acts on a vehicle which produces the side thrust. To sustain that side thrust force, the plane of wheel must make some angle with direction of motion of vehicle. This is achieved by distortion of tire thread. The angle between the wheel inclination and the path taken by the wheel is known as slip angle, as shown in figure. The value of slip angle depend upon the side force, flexibility of tire, load carried by the wheel and other factors such as camber angle and road surface. When the slip angle is greater at rear wheel than at the front wheel, the vehicle tends over to steer. That is to turn into curve more than the driver intended. That is oversteer, as shown in figure aside. That is when the slip angle is greater at the rear wheel than the front, the vehicle tends to oversteer. That is to turn into curve more than the driver intended. Oversteer is to turn the vehicle more than the driver's intention. And when the slip angle is smaller at the rear than the front, the vehicle tends to understeer. That is, the vehicle does not turn properly. The understeer is opposite to oversteer and is preferable because correction by driver involves rotating the steering wheel a little more in the direction of turn. That is, understeer is permissible as it can help the driver to achieve the vehicle stability by turning more the steering wheel. The oversteer reduces driver effort during cornering and has advantage while driving along road having many twists and turns. The understeer gives driving stability when there are strong side winds. It is best for fast driving and long straight roads. The understeer occurs when front tire start to slip. When slip angle at front and at rear is same, there is no tendency of vehicle to move away from path of the neutral straight line. This condition is called as neutral steer. Next point is basic components of an steering linkage. The steering linkage, depending upon which steering gear used, may be consist of an inner and outer tie rod assembly, steering wheel column, ball and socket joint, drag link, pitman arm, drop arm, etc. In all type of steering system, there is a steering cross shaft or a cross shaft in a steering box, which is operated by the means of steering wheel through a rod in the hollow steering column and some types of steering gear. The cross shaft is further connected to the drop arm, sometimes also called as pitman arm, at its end. Thus, the rotation of steering wheel results in linear motion of drop arm at its end, which itself is connected through a ball joint to a link rod. To meet different requirement of different vehicle, steering linkages having individual variations are used. Some important steering linkages are direct cross type, center arm steering, three-piece steering, etc. The steering linkage is adjustable to vary the toe setting and perform an alignment on the vehicle. This is necessary to account for tolerance in frame and suspension component, component wear and impact damage such as potholes. The steering linkage for rigid axle suspension is shown in below figure. That is the suspension having rigid axle at front. The steering linkage is used. The steering linkage for conventional rigid axle suspension, the link rod causes the turning of front wheel through the steering arms and the track rod. The track rod and steering arms are connected by the ball joints. The component of ball and socket joint is considered to be wear component. The design of ball joint is such that expanding spring compensates the wear, adjustment and misalignment in the system. A provision for change of the length of track rod is also provided. In this steering linkage, only one wheel is positively turning wheel or only one wheel is positively steered. This type of steering system is used for rigid axle suspension or in heavy vehicle or the vehicle which are having front engine rear wheel drive vehicle layout. The next type of an linkage is steering linkage for independent suspension system. In independent suspension, a provision has to be made regarding the motion of wheels relative to each other. That is to keep the steering geometry correct at all the time. Figure shows the steering linkage for independent suspension system. It shows two track rods provided at the front side and centrally idler arm is provided or actuate the two-piece track rod. In this case, both the wheels are positively turned. That is, both wheels are turned or both wheels are steered. In case of independent suspension, the two stub axles can move up and down independent of each other, due to which distance between ball joint ends of two track arm is continuously varying. On account of this, single track rod cannot be used. Instead, the three track rods are used and the center portion being called as relay rod. The other two are the track rod and the center one is called as relay rod. Relay rod is connected at one end to an idler arm supported on a body structure and to drop arm of the steering gear at the other end through ball joint. The relay rod is restricted to move in horizontal plane only. Movement in vertical plane is provided by outer portion, that is the tie rod about the end ball joints. In case of conventional rigid axle suspension, the main axle beam ensures movement of stub axle in horizontal plane only. In this, therefore, there is no vertical deflection of suspension and hence there is no change in effective track rod length. This type of steering linkage suspension system is usually used in passenger cars and nowadays vehicles. So this is it for today's session. In today's session, we have started our second control system, the steering system, in which we have started at the basic terms, completed the basic terms related to steering and the steering linkages. Thank you.